Welcome to today's session. See, recently, because of the unfortunate incident that took place in Meghalaya, the Rathole mining incident, there has been a lot of discussion over coal and coal mining in India. So today we are going to discuss about coal in India, its distribution, mining and future prospects. So let's get started. So now let's understand the process of formation of coal. So how did coal form? Okay, millions of years ago, Earth was filled with swampy forests. Okay, swampy forest, I mean marshy forest. That means there's a lot of water and on that forest grew. There's a lot of water and on the top of it there are forests. So that is known as a swampy or marshy forest. Okay, then naturally the plants will die, or the trees or the ferns which grew will die eventually, and those got covered with a top layer of soil or another layer. Okay, like that. Plants used to die, they used to get covered. Plants die, they get covered by layers, right? Like this, different layers were formed. And this you can see in this diagram. See, the vegetation here, this vegetation which is buried here got covered with different layers. And like this, as the layers keep increasing, no, they'll keep exerting pressure on the bottommost layer. And because of the pressure and because of the heat which the top layers create on the bottom layers, here in the bottommost layer coal and other minerals form. Coal, in this specific case, coal got formed, okay, over a lot of time. Here in this case, millions of years. Like you can see here, the swampy or marshy forest, then again layers got accumulated here, and finally the end product is here. Today there is coal and we are mining the coal in the industry, right? This is how coal got formed. Now let us look at the classification of coal. In the first method, the first classification method, there are certain forms of coal which we will discuss, like peat, lignite, and the others which I have not mentioned are bituminous coal and anthracite coal, right? In the beginning, when the swampy forests, the plants in the swampy forest die, right, there is a layer formed over it, and that would be called as peat. Alright, then afterwards, after few years, as the time passes with pressure and with heat, peat gets converted into lignite, right? And after few years, after application of more pressure and more temperature, that is more heat, lignite will get converted into bituminous coal. Alright, and after few years, after more application of pressure and heat, bituminous will get converted into anthracite coal. See, anthracite coal is the best quality coal. It has the highest amount of carbon, right? In terms of quality, if we talk, anthracite is better than bituminous, bituminous is better than lignite, lignite is better than peat. This is in terms of quality, that is in terms of carbon content. Anthracite has the highest, then bituminous, then lignite, and then peat. So naturally the amount of heat coming out of it, or the efficiency with which the coal is going to burn, is also in the same order. Anthracite will have the highest, peat will have the least. Now let us look at different varieties of coal in detail. So the first one, that is peat. See, this is the first stage of transformation, right? It will contain less amount of carbon, somewhere around 40 to 55%. That means it will have more impurities. It contains sufficient volatile matter and a lot of moisture. And that means, a lot of moisture means more smoke and more pollution. See, if you leave it to itself, it will burn like wood. It will give less heat and emit more smoke and leave a lot of ash. Coming to the second stage, that is lignite. See, it is an intermediate stage. Lignite is an intermediate stage. The color varies from dark to black brown. The moisture content in it is high. It is over 35%. It undergoes spontaneous combustion. Okay, this is bad because it can create fire accident in mines. Okay, now coming to the third stage, that is bituminous coal. It is soft coal, most widely available and used coal. It derives its name after a liquid called bitumen. Alright, it contains around 40 to 80% carbon, and the moisture content and volatile content is somewhere around 15 to 40%. It is dense, compact, and usually black in color. It does not have traces of original vegetable material like in the case of peat. Peat has the traces of original vegetable material, alright. The calorific value is very high due to high proportion of carbon and low moisture, and it is used in the production of coke and gas. Now coming to the last and final variety, that is anthracite coal. It is the best quality coal. Okay, it is hard coal. It has 80 to 95% carbon, very little volatile matter and negligible proportion of moisture. It has a semi-metallic luster, alright, and it ignites very slowly. That means less loss of heat and high efficiency. It ignites slowly and burns with a nice blue flame. See, if there is blue flame, it means complete combustion. Okay, for example, LPG, it burns with a blue flame, right? It shows more efficiency. In India, this kind of coal is found in Jammu and Kashmir in very small quantities. See, earlier we had looked into classification of coal based on the carbon, hydrogen and oxygen content, right, into peat, lignite, bituminous, anthracite, right? That is one type of categorization, and here we'll look at two more varieties of classification of coal. See, there are many more classifications of coal, okay, based on different criteria, but here I have explained, in this video I have explained only 3 classification methods of coal, and this is only to make things easier for us, right? So let's look at the second classification, coking coal and non-coking coal. See, coking coal, it is used to create coke. Coke is produced by heating bituminous coal without air to extremely high temperatures. So what is this coking? The process of coking is actually flushing out impurities and improving the concentration of carbon in the coal. So this kind of coal will have very high carbon content and less moisture, less sulfur, less ash, hence it will be more efficient. Now coming to non-coking coal. See, creating coke using non-coking coal is not economical. Why? Because non-coking coal has high sulfur content, and because of the sulfur it cannot be used in iron and steel industries like coking coal. Okay, hence the efficiency of non-coking coal is less. Now coming to the next classification, Gondwana coal and tertiary coal. See, this classification is based on the time period to which this coal belongs to. For example, Gondwana coal. Gondwana coal belongs to the Carboniferous period, that is 570 million years to 245 million years back. And tertiary coal. Tertiary coal is found in the rocks of the Oligocene period of the tertiary era. It is about 15 to 60 million years old. Now let us look at few important and major coal fields of India. See, here there is one in West Bengal, it is called Raniganj. There is Jharia and Bokaro in Jharkhand. There is Singrauli in Madhya Pradesh, and there is Pench and Kahan also in Madhya Pradesh. There is Talcher and one more in Orissa, and Singareni down in south. So these are few major coal fields of India, and there are certain lignite reserves in Tamil Nadu as well. Now coming to the Rathole mining in Meghalaya. See, there are different ways in which mining is performed. One is open cast mining. Then there is shaft mining. Alright, and then there is this Rathole mining, which is frequently occurring in northeastern state of Meghalaya, which is a big problem. Why? See, this coal which is obtained in Meghalaya has certain problems. For example, it has very less carbon content and very high sulfur content. See, with your previous knowledge of this video, you might understand that less carbon content and more sulfur content makes the coal less efficient, right? So it is not a very good quality and good efficiency kind of coal. That is one point. And the second point is, it has been, this kind of mining has been banned by the National Green Tribunal, yes, in its orders, but it is not being followed because of various reasons like greed of the people there and unemployment. There's a lot of unemployment in northeastern states around Meghalaya also, not just in Meghalaya but the states around Meghalaya also. There's a lot of unemployment and indebtedness. So because of these reasons, there's a lot of Rathole mining happening in Meghalaya. And there are other environmental factors also, like the pollution of the Kopili river. People are complaining of pollution in Kopili river because of the mining activities, the Rathole mining activity. There is acidification. Okay. So what exactly is Rathole mining? See, it involves digging of very small tunnels, usually 3 to 4 feet high, which workers enter and extract coal from. These workers are usually children, and the Rathole mining is broadly of 2 types, right? One is side cutting and the other is box cutting. Alright, side cutting and box cutting. In side cutting procedure, narrow tunnels are dug on the hill slopes and workers go inside until they find the coal seam. Alright, and the coal seam in hills of Meghalaya is very thin, less than 2 meters in most cases. So this is also one problem with the coal in Meghalaya. See, if you look at coal fields in Jharkhand, where the state is very rich in such resources, the coal seam is quite thick in hundreds of meters, but here the coal seam is just 2 meters. In the box cutting type, a regular opening is made, alright. It varies somewhere between 10 to 100 square meters, and through this a vertical pit is dug, which is 100 to 400 feet deep. And once the coal seam is found, the rat hole sized tunnels are dug horizontally through which workers can extract the coal. So you'll understand these procedures of side cutting and box cutting better with the help of this diagram. See, here in side cutting, narrow tunnels are dug on hill slopes and workers just go inside until they find the coal seam. That's it. That's how side cutting is done. It's simple. But in box cutting, the rectangular opening is made here like this, and from there, once the coal seam is found, rat hole sized tunnels are dug horizontally through which workers will extract the coal. That means like this, there will be a tunnel, the rectangular box tunnel, then there will be a vertical, and then again horizontally they'll come out. Okay, this is box cutting type of a rat hole mine. So with this we have come to the end of today's session. Here we have mentioned a few model questions. Please answer them. See you in the next session. Thank you.